Okay, so this is the last type of factoring we're going to learn in this chapter. So far we have done the following. Common factor. When should you check for common factors? Yep. If they're like terms, so anytime you're given a factoring question, you should always check for common factor. How do I know I'm supposed to do group factoring then? What's the hint? That it may be a group factoring. 4 terms. So when there's 4 terms, that's when you want to consider group factoring. Triangle factoring, we did trinomial factoring, Trinomial, we did 2 different methods. We did the triangle and square method when the coefficient is 1, and the cross method when the coefficient is not 1. Okay? And then today we're going to do the last type, perfect square factoring. So why it's called perfect square factoring is because it deals with perfect square. What are perfect square numbers? Yep.
That can be square rooted and have like an integer.
Okay, so give me some examples.
So 9, 25.
Okay, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. And so basically these are perfect square numbers. Why I wrote these numbers down is because you have to recognize this. If you recognize the perfect square numbers, you can see if they're perfect square factors. So my coefficient for A right here, it's a 9. And the coefficient here, the constant here is a 1. Are these both perfect square numbers? Yep. All right, so if it's both perfect square numbers, I can do this. So just like yesterday, we could do the cross method. When we do the cross method, you'll see that it's 3a and 3a. And this would be 1 and 1. All right. My middle term is negative. This term is positive. So what do the 1s have to be? Yep.
1 negative, 1 positive.
I'll do this. So for example, this, we have the 3a and the 3a, and then we have the 1 and the 1. When we cross multiply, we don't get that negative 6a. So what do the 1s have to be? Negative 1 and negative 1, right? So here, when I write my 2 brackets, it's 3a minus 1 times 3a minus 1. If I want to factor it fully, what's my fully factored answer?
3a minus 1 squared.
Perfect. Yeah. Okay. So if it's a perfect square factor, you can see it's nice and easy to get my 2 numbers. It's basically split. Okay. This one right here, example 2. What's my first step? Yeah, 2y and 12. 2y and 12. But before that, common factor. Yes, there is something common in all 3. So what can I divide all 3 by? What goes into all 3? Does 4 go into 144? I think so. 144 divided by 4. Yep, it goes in. So 4. 4 goes into all 3. So 4 bracket y squared plus 12y plus 36. Okay. Okay, what type of factoring should I use here? Yep. Sorry? Perfect square. This is still a perfect square factoring. 1 y squared and 36. 1 and 36 are both perfect square numbers. So what do you think my 2 brackets is going to be then? So the y is going to be split it into y and y. For 36, it's going to be the fruit fly is still here. Sorry. So what do I split the 36 into? Yep. 6 and 6. All right. Since all of my signs are positive, what do you think the signs are going to be? Positive. So how do I write my final answer? Kelly? Good. All right. Now let's say I did really forget to do common factor first. When you do the if you just factor without doing the common factor first, you'll get this. Okay, that's what Arian said. And then you can see, oh, I actually have a common factor here, it's a 2. I have another common factor here, which is a 2. So when I bring both 2's out, I'll still get that 4. Okay, so eventually you'll get to here. But when you do common factor first, you deal with much smaller number, less likely for you to forget about that. Yep.
Are there cases where one of the not terms like some of the brackets
Are there any cases where it would be y minus 6 and y plus 6?
That's our example 3. All right, example 3. Okay, 4x squared minus 81. So is 4 a perfect square number? Is 81 a perfect square number? Yeah, so I know this is a perfect square factoring. 4x squared, what do I split that into? Yep. Sorry?
This is different squares.
We're getting to that. So how do I split the 4x squared? Arian? 2x and 2x. What about the 81? What can I split that into? 9 and 9. So now, this is Ryan's question. If there's no middle term, it means that the signs are one is plus, one is minus. Because when we do FOIL, what happens to the middle term? It gets cancels out. So that's why there's no middle term.
It's like the middle term has a value of 0. So
But if there is a middle term, it's always the same sign.
Yes.
we can think about this is like the middle term has a coefficient of 0. So therefore 9 minus 5 is like is 0. So
Yeah, but it's also because when you do FOIL, you have the 18x minus 18x, and so that's why the middle term is canceled as well. All right. Example 4. All right, example 4. Yep, that's okay.
So if the middle term is positive, will the signs you use always be positive, or do you have to check to see if that works the rest of the
If the middle term sign is positive, that means your both signs is positive. If the middle term sign is negative, then both is negative. Yeah, because they have to be the same bracket. So in that case, it will be. Okay, example 4. So it doesn't have to be the x squared term first. It could be your constant that goes first. So 16, 36, are they perfect square numbers? Yeah. All right. Oh, actually, before I do that, yeah. Yeah. So what can I take out from both? Yeah, I can actually take out 4 out of both. So, and what's neat is if it is a perfect square factor, even after you take out a common factor, it's still a perfect square factor. So I see the 16 and 36. I know it's perfect square numbers, so I jump right into it. But even if you do this, even if you factor out a common factor, you can see that it's still a perfect square factor. Okay, so then I have the 4. What are my 2 brackets then? How do I break up the 4? Yep.
2.
2 and 2. And then the 9x squared. Yep.
Minus 3x and plus.
And plus 3x. Perfect. Yep, that's it. Okay. Last example. No numbers. Okay, if there's x squared is still a perfect square because it's x times x. Y squared is still a perfect square because it's y times y. So what would I write in my two brackets?
X plus y, x minus y.
Yeah. So you would split it the same way. Split the x, so x and x. Split the y, y and y. Since there's no middle term, that means one is plus, one is minus. What do we call this type of perfect square? What do we call this? There's a special name for this type of factoring. What's the, yep,
Difference in square.
difference of squares, right? So this is called difference of squares. Okay, this is a special type of expression, right? And it's called difference of square. Okay, so a note. So this is the summary basically that Ryan was asking for. If the middle term is positive, then you know that it's positive, positive. If the middle term is negative, then you know that it's negative, negative. If it's a minus with no middle term, then it's a plus and a minus. Which is example 6. Which is example 6 right here. Factor this. Okay, I see the 9, which is a perfect square. I see the 4, which is a perfect square. How do I factor this one? Okay, who has an idea? It's a trick question. Okay. Kelly? I can't. That's right. I can't. Why? Why not? Yeah. Difference of square. What does the word difference mean again? Subtraction. Right. So in order for it to be a difference of square, it has to be negative. Subtraction. This one, why it doesn't work is because let's say you write 3x plus 2y and 3x plus 2y. If it's plus plus, you're gonna get a middle term. If you do minus, you don't get the middle term, but then the sign here would be subtraction. Yeah, and if it's both negative, you'll also get a middle term. So there's no way that you could have a positive and not have a middle term. And so that's why you can't factor this. And this is just as this. Just like your homework question, factor if possible. So some are not possible.
So you can't factor a binomial in the middle to like using the middle to plus.
Only if there's a common factor, for example. If there's a common factor, then you can factor a common factor. But other than that, nope.
It's like if you write 9x squared minus negative 4y squared. Negative 4y squared isn't even a square. So
Yeah. Okay. Yeah, you can think of it like that too. Okay, so nice and easy lesson today. 14 minutes. Try these ones right here. Questions 2, 4, 6, A, C, E, G only, and then number 7 and 8. Answers are attached. What was today's lesson called? Yeah, perfect square. So when you try to look for the homework, look for the one that's called perfect square. Makes sense, right? Perfect square factoring. Right here. So the first 2 pages were my lesson, and then these are the questions and answers. All right.